For problem 111, you just need to remember this expression. It's a method of focusing by changing the number of crystals. The correct answer is aperture focusing, which is option C. I'll provide additional explanation about this with a diagram. The concept of aperture focusing can be easily understood by thinking of a camera lens. In this way, the aperture size inside the camera lens changes, allowing the focus to be adjusted. This is how it works. Based on this explanation, if you look back at the main text, you'll see that the shape of the focus changes depending on how many crystals are used. For example, if you use a large number of crystals, you will have an aperture of a larger size. If you use crystals of a smaller size, you will have a correspondingly smaller aperture. These changes in size allow you to create different focal points. You can consider this concept to be related to the sentence about aperture focusing in section C. Therefore, to make solving problems easier, try to recall the concept of focusing here by thinking of a camera lens. As you solve problems, remember that there are such expressions related to this sentence. Let's move on and look at the next topic. In this question, you are asked to select a probe that has a sector image shape. The sector image is associated with two types of probes. These are the phased array method in section B and the annular array method in section C. So the correct answer would be to select both B and C. Or sometimes these two options are given and the question asks you to select only one. In that case, you should choose the phased array method, which is option B. Since the annular array method is hardly used anymore, if you are asked to choose between the two, selecting the phased array method should make solving the problem much easier. So, if both options are included in the choices, as in this question, you should select both. If the question specifically asks you to choose only one, I want to emphasize once again that you should select the phase difference method in option B. Next, let's move on and look at question 113. For questions related to probes, it's more important to organize the relevant keywords well rather than focusing on detailed concepts. In the question, it mentions a rectangular element, which refers to a rectangular shape. Next, the straight line, which refers to an arrangement that extends in a single row, corresponds to the linear array method in option B. You just need to check the keywords carefully while solving the problems. Next, let's move on and look at question 114. This question is about selecting the statement related to the characteristics of a linear array transducer. This is one of the concepts that many people find confusing. Also, as a tip when solving these problems, remember that the linear array method does not have a good relationship with cross-sectional thickness. What this means is it's referring to the elevational direction, which is the same as cross-sectional thickness. The question is asking what kind of focusing is achieved in the elevational direction in the linear array method. As I just explained, I mentioned that they do not have a good relationship. Options A, B, and C are representative electrical focusing techniques. These methods improve image quality and can be considered better techniques. Option D, on the other hand, uses mechanical focusing, which is considered an old-fashioned method. It can affect image quality, and these aspects have disadvantages compared to electrical focusing. Once again, as I mentioned before, these two do not go well together, so you can summarize that it is more related to old and less favorable methods rather than good ones, which will make solving the questions easier. Therefore, you can choose option D as the correct answer. Of course, there is a way to study this in detail physically and understand it, but that takes a long time and tends to make it difficult to organize the concepts clearly. Therefore, when solving problems, I would recommend approaching them more simply and choosing the answer, as this saves time and is more efficient for understanding the content. Yes, additionally, I will explain the linear array method using a diagram. If you look at the diagram, it is an image comparing the general array method and the phased array method. For the sequentially arranged array method, you can think of it like the keys on a keyboard. In this way, it has the characteristic that the pulses proceed sequentially. On the other hand, with the phased array method, the time interval is extremely short, so you can think of the pulses as being emitted almost simultaneously. Due to these differences in method, each has its own advantages and disadvantages. In the case of sequentially arranged arrays, the frame rate is lower, but the image quality is relatively better. On the other hand, with the phased array method, since the pulses are emitted simultaneously, the frame rate is higher. However, compared to the sequential array here, the image quality is somewhat lower. That's another difference to note. Additionally, when the image is generated, this method produces images in a linear, rectangular fashion. Here, you should also remember the difference that a sector image is produced. Yes, these parts can be a bit confusing, so the questions don't get extremely detailed. But if you know this content, I think you'll understand the questions better when solving them. Let's return to the main text and look at the next question. Question 115 is one of the important concepts that is frequently asked. Among the characteristics of transducers, the most notable feature of an annular array is that the beam axis is emitted uniformly. Also, when you study, make sure to remember the features related to annular arrays, as questions about them are always included. You should note through problem solving that these expressions here are related. Next, let's move on and look at question 116. This question includes some rather complex concepts, so I will focus on explaining only the necessary points. Yes, this question is asking about the disadvantages of using a small footprint. This small footprint refers to the small size of the probe. When the diameter of the transducer becomes smaller like this, the ultrasound beam quickly focuses and then rapidly diverges, which is a disadvantage. Therefore, proper focusing may not be achieved. Next, because the beam spreads out widely, it has the disadvantage of reduced lateral resolution. To summarize once again, when using a small footprint, the beam quickly converges and then diverges, so these issues are related to the fact that proper focusing is not achieved. Next, as the beam divergence increases, a decrease in lateral resolution may occur. You just need to remember these 2 points well. You could say that the correct answer to the question is here. Just pay close attention to the expression decreased focusing here. In the latter part, there's a term called twice depth, depending on the aperture, but you don't really need to know this part in detail. Just make sure to check how focusing changes and its relationship with a small footprint. Next, let's move on and look at question number 117. This question is also a frequently appearing pattern, so let me emphasize that before we begin. The task is to find the option that is not related to improving axial resolution. The correct answer would be the statement about increasing focusing. The keyword focusing is related to lateral resolution. So the correct answer is probably this one, so we can consider this as the answer. From option A to option D, on the other hand, these are keywords that actually help improve axial resolution. Through solving these kinds of problems, you can organize your understanding by noting that these options improve axial resolution, while an option like this one is not related. So, since axial, lateral, and slice thickness are all important, it would be good to make sure you organize and review any related questions. Let's move on and look at the next question. This question is about something I explained earlier. Yes, this is a question about selecting the transducer that creates a sector display where the top is narrow and it fans out in a sector shape at the bottom. In the previous question, I mentioned that these two types were applicable, but in this question there is no option that includes both. So in this case, you should choose the phased array in option B. Actually, questions like this are a bit controversial, so they are not often included in exams, which means it's not a particularly good question. But just in case it does appear on a test, it would be good to remember this as a reference. Let's move on and look at the next question. Since this question covers basic content, let's find the answer right away. We can expect that the intensity of the sound beam increases the most when the beam is most focused. The correct answer would be the focal point, which is option C. Next, let's move on to question number 120. For this question, it's most efficient to study it as a simple memorization pattern. The first keywords are constructive, destructive, and then interference. Terms related to interference appear. You might see expressions like constructive and destructive interference continuously combining. Secondly, the term sound source usually appears together as well. Once again, when constructive and destructive interference occur and the term sound source appears, it refers to a sentence about Huygens' principle in question number 2. Of course, studying Huygens' principle in detail from a physics perspective can be helpful, but the keywords that appear in the questions are already set. So when these terms appear and sound source is mentioned, you can consider it as a concept related to the Huygens principle shown here. I can tell you that if you study using simple memorization patterns, you can solve problems more efficiently,